Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Math Wednesday. Thank you so much, Dr. A, for that wonderful introduction. I'm so glad to be back with you today. Last week, Priya did an amazing job doing Math Night Wednesday because I was unable to be here, but I am happy to be back. As Dr. A said, if you shoot us a text message at this number right here, we will go ahead and get these slides to you. You will not have the notes. You will just get the blank slides. But it's an excellent way to practice these problems on your own after this session. So if you want these practice problems, shoot us a text at the number below, Math Stream 1, and we will make sure that we get these problems to you. Before we get busy, I always like to start with a welcome question because it helps me understand where you're coming from. So I would like you in the comments to let me know where you're from, what test you're studying for, and what college you graduated from or are currently attending. So I went to UCF for my both my master's and my bachelor's degree. So go Knights. I currently still live in Central Florida, and I am a math coach, ironically. So that's a little bit about me. I cannot wait to learn more about you. So like I said, in the comments, let me know where you're from, what test you're prepping for, and what college you went to. So without further ado, let's go ahead and get started with our first problem. Today is a data and statistics edition of Math Wednesday. So I pulled data and statistics problems from a variety of content standards that will hit anywhere from pre-K through 12th grade math, regardless of what state or what test you're studying for. I love data. Statistics is not my favorite, but it's still important that we review it and go over it because it will be on your assessment. We all have things that we love about math. We all have things that we are not our favorites, and I'm just going to be raw and honest. Statistics is not my favorite, but we still have to understand how to do it, how to use it, and how to apply it to our assessment. Our first problem is not a data and statistics example. It's an example from one of the weeks before that we didn't get to finish. So let's go ahead and jump into our first problem. Again, this problem is not data and statistics. However, it's a problem we didn't get to finish 2 weeks ago. So we're going to go ahead and go over this problem. Hello from Colorado. Oh, man, I wish I could be in Colorado right now. We love to ski, my husband and I. And so we've skied in Canada. We've skied in Maine, but I would love to get out to the West Coast. One of our best friends lives out there. Anyways, squirrel, moving on. Joelle is building a triangular garden where one of the sides of the garden will be the entire 8-foot side of her home, and one of the other sides of the garden will be the fence that runs perpendicular to the side of the house. If the third side of the garden is 15 feet, what is the area of the garden round to the nearest thousandth? Hey, Hope, welcome back. I missed you last week. So let's go ahead and draw a picture of this, because anytime we're doing a geometry problem, if I can draw a picture, you know I'm going to. So we know that this is a triangular garden. We know that one of the sides will be the side of her home. So let's go ahead and draw a quick picture. We've got her home. I need to draw a much smaller picture. We have her home. And then we know that this is going to be one of the sides of her garden. The other side of the garden will be the fence that runs perpendicular to the side of the home. Right there, we see an important vocabulary word, perpendicular. Perpendicular means creates a 90-degree angle. Creates a 90-degree angle. So I know that the fence is going to look something like this, and we'll pick at that fence right here because it's going to create that 90-degree angle up against the side of the house. Then it says the third side of the garden is 15 feet. So we know that this side right here is 8. We know that the fence is some measurement. And we know that the third side of the garden is 15 feet. And we know that this created a 90-degree angle. So if we're trying to find the area of the garden, I'm going to have to do area equals 1/2 base times height. Depending on the exam you're prepping for, you might have a reference sheet that offers those area formulas for you. If you don't get that, you got to know that the area of a triangle equals 1/2 base times height. Height being the perpendicular height to the base, not the slanted height. So in this case, if I flip my triangle the right side up, I guess, if you will, I would have, and I'm going to use the same colors, I would have the house, I would have the fence, and I would have the 15. So 15, 8, but that is my height, but I don't have my base. I have this weird slant height, but I don't have my base. So how am I going to find this base if I'm only given my height and my hypotenuse is what that's called? All important vocabulary. Here's what I do for those of you who are new. I try to throw a bunch of vocabulary at you, even though it would not normally take me this long to solve a problem. Hypotenuse. I try to throw a bunch of vocabulary at you so that you can really understand the scope of the problem. And let's be real, we've got pre-K through 12 people in here, and we have a variety of ability levels. So it's important that we understand the whole scope of the problem. It would not normally take me this long to solve this problem. So the way I'm going to solve this is I'm going to use the Pythagorean Theorem. A squared plus B squared equals C squared, where C squared is always your hypotenuse. This only works for right triangles. So I can only use the Pythagorean Theorem for right triangles. Because this is a right triangle, because it has a 90-degree angle, I can use it. So I can do 8 squared plus b squared equals 15 squared. 8 squared is 64, because remember, an exponent means do that thing that many times. So 8 squared is the same thing as 8 times 8 plus b squared equals 225. I just happen to have those memorized. If you don't, that's okay. You have a calculator, some of you, that you can use, a 4-function calculator. If you do not have a 4-function calculator, you may want to memorize some of those basic squares and square roots. So I'm going to move over here because I'm running out of space. 64 plus b squared equals 225. Subtract 64 from both sides because I'm trying to isolate that variable. I'm trying to get that guy by itself. So b squared equals, I am going to use my calculator to subtract 161, and the square root of 161 is 12.6869. We'll call it 69, square root, both sides. That is the base. So B equals 12.69. Now, I still haven't found my area. So 12.69 is the length of my base, or the fence line. It is not the area of my triangle. So now I have to find the area of my triangle. This is a multi-step problem. It's important that you can come up with your plan and then execute your plan before we solve a problem like this. So let's go ahead and solve for area now, where we know area equals 1/2 base times height. So half of 12.69, which is my base, times my height, which is 8, is going to equal 12.69 times 8 divided by 2 gives me 50.76. So our answer is going to be C. You'll notice that the answer choice was 50.75. That's because they did not round prior to multiplying. So when they solved it, they didn't round this number. They kept that really long number of 161 square rooted. If I square root that, you'll see it's a really long number. They didn't round that off. So, but we are very close. So we got 50.76. So multi-step problem, you've got to know how to solve multi-step problems. You've got to be able to have a plan and execute that plan. Let's go ahead and go into now, because remember, I told you all that this is the data and statistics edition. That was a leftover problem. So let's jump right into our first data and statistics problem. The average lifespan of an elephant is 65 years with a standard deviation of 12. Which of the following is the best interpretation regarding the previous statement? The median lifespan of an elephant is 65 years. Most elephants live to be older than 53 years. Most elephants live to be between 77 and 89 years. The longest living elephant lived to be 101 years. So let's go ahead and break this problem down. Again, if I was doing this problem and I knew a lot about standard deviation and how it works, I would be able to solve this problem in 30 seconds. It's not the goal tonight. The goal tonight is not to be able to solve it very quickly. The goal tonight is to be able to really explore these problems and give you a depth of understanding. So they're kind of like mid-math in every problem. So let's go ahead and talk about standard deviation. Standard deviation is your typical bell curve. Hey, Virginia, welcome from West Virginia. So we have a standard bell curve that looks like this. You might have heard of a bell curve when it comes to like grades. A bell curve is just a distribution of data. So if we think about grades in a class, or the age of an elephant at all the zoos in the world, or shoe sizes of the kids in a first grade room, all of that is different numerical data. And so when we have numerical data, we can create a bell curve where the very middle of the bell curve is going to be your average or your mean. And then off of that middle point, we have what's called the standard deviation. So the standard deviation for GK or some of the like middle school, you do not have to find standard deviation. They will give you the standard deviation and you have to be able to interpret it. So from your average, you have 1 standard deviation, 2 standard deviations, 3 standard deviations. So we have 1 standard deviation here, 2 standard deviations, 3 standard deviations. And then we have 1 standard deviation, 2 standard deviations, 3 standard deviations. And I'll go ahead and write that. 1 standard deviation, 2 standard deviations, 3 standard deviations, and then 1, 2, 3. I would encourage you, if you don't understand this and you know it's going to be on your exam, that you take a picture of this bell curve when I'm done. From there, we know that 34% of your data is going to fall between the average and 1 standard deviation. 34% of your data is going to fall on the other side of 1 standard deviation and your average. 13.5 is going to fall between 1 and 2 standard deviations. And 2.5 is going to fall between 2 and 3 standard deviations. And those numbers are a little bit wiggly. Some graphs you see, it'll be 3 here and 14 here. Some graphs will be 2 and 14. So those numbers are a little bit wiggly, but that's not the point because I'll explain that in a minute here. Because really we're just interpreting this data. So all that said, again, most of the exams are not going to require you to find standard deviation unless you are doing a high school exam. And even then, some of the high school exams don't require you to find it. You need to look at your blueprint, or if you have a specific question about that, feel free to reach out to me on our Facebook page. So with this problem, our average is 65. So I'm going to put a 65 right here for our average. Then it says standard deviation of 12. So what is 1 standard deviation away from 65? I know 1 standard deviation equals 12. So I'm going to add 12 to 65 on this side, and I'm going to subtract 12 on this side. So I'm going to go ahead and pull out my handy dandy calculator. 65 plus 12, 77. 89 is 2 standard deviations away, and 101 is 3 standard deviations away. Then I'm going to subtract 53, 41, 29. What does all of that mean? All of that means that 34% of your data is going to fall between 65 and 77. That means 4% of your elephants are going to be 65, 66, 67, 68, 69, 77, all the way to 77. And 34% of your elephants are going to be between 53 and 65. 13.5% of your elephants are going to be between 77 and 89 and 41 and 53. And then 2.5% of your elephants are going to be between 89 and 101 and 29 and 41. When you add all those percentages up, it equals 100. That does not mean we can't have elephants that are 12 years old or 120 years old. It just means that most of your data is going to fall between 20, well, not most of your data, but the majority is going to fall between 29 and 101. So, but you can have those outliers because you and I both know we've looked at data sets that have outliers. So, moving on. The median lifespan of an elephant is 65. Do we know that? We don't. We only know that the average is 65, and we know the standard deviation. But were we given a data set? No. I need you to pay attention to that important piece of information. They will try to catch you on answer choices like A and like D, because it says the longest living elephant is 101. Well, guess what? That's the highest number I have on my bell curve, but that does not mean that's the oldest elephant. That just means it's the highest standard deviation when we're 3 standard deviations away, but I could have an elephant that's an outlier. So if you have a problem where you're interpreting standard deviation and you are not given the data set, you cannot find the longest, the oldest, the medianest, the biggest, the smallest, because we've not been given our data. So I can automatically cross those answers off. A and D are gone. But what I can do is I can look at the most. I can look for most, because most just means more than 50%. So if most of my elephants are older than 53, or most of my elephants are between 77 and 89, I can look to find that percentage on my bell curve. So let's go ahead and highlight in purple, older than 53. Older than 53 is going to be anything from 53 and on. Now let's go ahead and highlight between 77 and 89 in yellow. That's going to be this section right here. So this is only going to equal 13.5% of our elephants. And this is going to equal 34 plus 34 plus 13.5 plus 2.5% of our elephants. So most of our elephants are going to be older than 53 because that is greater than 50%, which is most. So when we're interpreting standard deviation problems, we just have to be able to understand this graph to be able to interpret standard deviation. Again, most of you don't have to find standard deviation using the formula unless you are taking a high school exam. And even then, only some of the high school exams require you to find standard deviation. As I am solving these problems, I want you to ask me any questions that you have in the comments. If you have any questions in the comments, feel free to ask them in the comments below. And I apologize, Dr. A is actually calling me right now. So give me 1 second. I am telling him I am currently live with you guys. So I apologize. I might have to take that because he is the one that runs this show. So let's go ahead and keep going. If you have any questions, please let me know in the comments below and let me know, and I will be glad to answer them. I love when you guys ask questions because it allows me to really target my answers to you. So if you have questions, let me know. Let's go ahead and go to problem number 3. The average height of the guests at a local theme park is 52 inches with a standard deviation of 3 inches. Which of the following is the best interpretation regarding the previous statement? I just took another standard deviation problem so that we could do this one a little bit quicker. So let's go ahead and snapshot this graph right here. So that we can reuse it. I'll just erase the little pieces that we don't need. So we don't need the blue, we don't need the green or the purple or any of these numbers, but we can use this same graph for this problem because we know this is standard deviation. If you didn't get a chance to take a picture of that graph on the last slide, snap a picture of it right here. Here, I'll even zoom it in for you. Snap a picture of this because you need this information to be able to interpret standard deviation. So the average height of the guests at a local theme park is 52 inches with a standard deviation of 3. That tells me I know I'm working with a bell curve where I'm interpreting my standard deviation. So my average is 52 with one standard deviation being 3 inches. So I'm going to add 3, add 3, add 3, subtract 3, subtract 3, subtract 3. So let's go ahead and use my calculator. Actually, I shouldn't need my calculator for adding 3. 55, 58, 61. And then I'm going to subtract 3, subtract 3, subtract 3, and I'm going to get 49, 46, 43. What does that mean? That means that one standard deviation away from 52 is 55. 2 standard deviations away is 58. 3 standard deviations is 61. Which of the following is the best interpretation? I'm going to automatically get rid of 2 answers because we were not given our data. Unless we are provided with a data set, we don't know the tallest guest and we don't know the median. We can't solve for that because we've not been given our data. Let's look at B and C. Most guests are taller than 52 inches. Most guests are between 52 and 55 inches. So let's go ahead and highlight and find which one of those is going to be 50% or more. So most guests are taller than 52. That's going to be any of these. Most guests are between 52 and 55. That's only going to be right here. So the yellow provides us with more guests than the blue does. So therefore, most guests are taller than 52 is going to be the correct answer. I'm hoping that this is helping clear some of this concept, some of these concepts up for those of you who have to do standard deviation. Let's go ahead and move on to the next problem. A high school surveyed 550 students. The students were asked how many hours they spend watching TV a week and whether they watch cable or use a streaming service like Netflix, YouTube, Hulu, etc. The results are shown below. What percentage of the students watch TV for more than 3 hours a week? So this is a two-way table. This is a table that's showing us multiple pieces of data on one platform. So let's just interpret what this table is even telling us. This table is telling us they surveyed a total of 550 students. So theoretically, all of these numbers should add up to 550 because that's our total surveyed students. Let's just cross-check that to make sure. 224 plus 54 plus 61 plus 83 plus 102 plus 26 equals 550. So the total number of students is going to be reflected in that table. That said, they didn't have to tell us how many students they surveyed because the students, if it says they had to respond, they didn't have to give us this information. You would have to deduce that there were 550 students total by adding all of those up. So we were very lucky that they gave us that information. They did not have to. Moving on, the students were asked how many hours they spent watching TV a week. So the number of hours that they spent watching TV a week can be reflected right here. And whether they watch cable or a streaming service or whatever is reflected right here. So what this means is there are 26 students who watch cable for 0 to 1 hours, and there are 102 students who watch streaming services for 0 to 1 hours. There's 61 students that watch cable for 2 to 3 hours, and there's 83 students who watch a streaming service for 2 to 3 hours. And all the way down the line we could go. So it says, what percentage of the students watch TV for more than 3 hours a week? Well, we have to capture all of the 3 hours per week. So we have to capture the cable and the streaming service, because the streaming service is also television. So what percentage, we have to put a part over a whole. If it's asking us for what percentage, we have to have a part over a whole. I know my whole is 550 because that's how many students were surveyed. Now, what is my part? Well, I'm just going to take the 3 hours, add those numbers together, and then that will be my part. So 54 plus 224 gives us 278 over 550. Now, don't forget decimals, fractions, percents, and ratios all represent the same thing. They're just different ways to represent the same number. Decimals, fractions, percents, and ratios all represent the same thing, just in different formats. So this is the fraction form of the percentage. How do I find that percentage? Well, I'm going to go ahead and divide that in my calculator to find out my decimal, and then I can convert the decimal into a percent. So this divided in my calculator, and if I didn't have a calculator, I would do it by hand, equals 0.50545. That being said, when I convert that into a percent, when I convert a decimal into a percent, I'm going to hop my decimal 2 places to the right. So I'm going to hop 2 places to the right, and I'm going to get 50.545%. If I was converting a percent to a decimal, I would hop the other way. So I would hop from where it is 2 places to the left to convert percent into decimals. So when we look at that and we round it to the nearest percent, we know that's 51%, which is the answer. Excellent job. Let's go ahead and move on to the next problem. A very similar problem. It's that 2-way table, which shows 2 different sets of data all on one table. So let's go ahead and read it and interpret it. The shown data represents the relationship between curfews and grade point averages among 30 students. Which of the following conclusions about the 30 students is most appropriate? A, students who do not have curfews do better than students with curfews. B, having a curfew guarantees high grade point averages. C, having a high grade point average results in a curfew. D, students who have curfews tend to do better than students without one. E, students with curfews are likely to go to college. All right, this is an interesting problem because it's asking us to interpret this data surrounding curfews and grade point averages. And you will also often see interpretations on line graphs as well, or dot graphs, graphs that look something like this. And you have to find the correlation. So really what we're doing here is trying to find that correlation. So let's go ahead and look at the pattern before we start to try to interpret the answers. So if students have a curfew, let's go ahead and look at that. If students have a curfew, more of them have a higher GPA than a lower GPA. So it looks like from that a curfew could show a positive correlation. No curfew, let's look at that. If students don't have a curfew, there are only 5 kids with a 3.5 GPA and 11 below a 3.5 GPA. So it's showing that kids without a curfew tend to have lower GPAs. Let's go ahead and look at our answer choices. Students who do not have curfews do better than students with curfews. Students who do not have curfews do better than students with curfews. Well, that data is not showing to be true because no curfews, there are less students with a higher GPA. So we're going to cross that one off. Having a curfew guarantees a high grade point average. Well, unfortunately for these kids, that did not happen. Having a curfew did not guarantee that high grade point average for those 4 kids. There's a lot of factors that go into this. So when you see guarantees in a data analysis problem, you can pretty much guarantee that that's not going to be the correct answer. Overall, very strong statement words like that, guarantees, results in, often will not be your correct answer. I'm not saying never, but it will likely not be your correct answer because we always have outliers. So B is not correct. Having a high grade point average results in a curfew. Well, for these kids, they have a high grade point average, but they don't have a curfew, so their high grade point average did not result in a curfew in that case. So that's not correct. And that's another one of those really strong words that we want to avoid when we're doing data analysis. Students who have curfews tend to do better than students without one. Tend to is a very common statement that they'll use when we're looking to analyze data because it shows a trend, but it's not showing a certainty. Because again, we have those outliers. Elizabeth, yes, absolutely. D is going to be the correct answer because students who have curfews tend to do better than students without, but it's not a guarantee. Students with curfews are likely to go to college. This graph has nothing to do with college. So no, that is not correct because there's nothing about college entry, college graduates, nothing like that. So we can't deduce or assume that from this data. So D is going to be the correct answer. For those of you who are joining us a little bit later, don't forget to text the number on the bottom of the screen to MathStream1, and you can get a copy of all of these, of this slide deck with all of these problems for you to go ahead and do later. All right, let's keep going. Problem 6. Students were measuring how much water can fill a large jug and how long it would take the water to fill the jug. Which of the following would be the best choice to represent this data? A histogram, a pie chart, a line graph, or a box and whisker plot? A histogram, a pie chart, a line graph, or a box and whisker plot? So let's go ahead and just quickly review what each of these is. Now, this is one of those problems you either know it or you don't. So would I spend 15 minutes sitting here, 10 minutes, 5 minutes, 2 minutes doing this problem if I was actually taking an assessment? I would not. I would read it. I would quickly think about what each of these graphs is, and I would pick an answer and move on. But I want us to really get what each of these graphs' purposes is so we can go ahead and make the best choice. A histogram is going to be something that looks like this. It's going to be what you and I might call a bar graph, where you have a set of data here and then a set of data here that you're comparing the heights of. A pie chart is just that. It looks like a pie, and a pie chart is going to typically look at a percentage of a whole. So we have 100%, and we're looking at what percentage is broken down. A line graph is going to look something like this, where we're looking at an X and a Y, or a dependent and an independent variable, and how they interact. And then a box and whisker plot looks something like this. No, a box and whisker plot does not look like that. That's a stem and leaf plot. A box and whisker plot looks, no, that was correct. Now I'm confusing myself. Box and whisker plot. Now I'm confusing myself between box and whisker plot and stem and leaf plot. That is a box and whisker plot where you have your average and your highest data point and your lowest data point, and then your interquartile ranges in the middle. So which of those would be best to represent how much water can fill a large jug and how long it would take to fill the jug? I immediately think of line graph. Why do I think of line graph? Well, a pie chart only looks at one variable. So we surveyed 500 people and each of them chose their favorite sport. What do those sports look like on a pie graph? And so that's what a pie graph is going to be best for. A histogram is going to be best for truncated data. But when I'm filling a jug over time, I'm not truncating that data. It's going to go on and on and on until that jug is full. And the water doesn't go plop and then stop, plop and then stop. I'm trying to figure out how long it's going to take for that steady stream of water to fill that jug. And so if I look at a line plot with time as my independent variable and how full the jug is as my dependent variable, I can see that at 0 minutes, my jug has no water in it. But as time ticks on, it's not 1 minute, 2 minutes, 3 minutes. It's 1 minute and a half a second, 1 minute and 1 second, 1 minute and 2 seconds. So it's continuous, which is why that line graph is going to be best for this kind of problem. So really understanding what is going to be best for measuring data is going to be critical for my pre-K through 6 people, because those are often the kinds of questions you're going to get about data. Let's go ahead and keep going. A second grade class took data on their favorite ice cream flavors. How many students were surveyed? Now, a lot of the problems we've been doing have been perfect for our middle school and high school folks. However, I wanted to make sure that we addressed some problems that really hit our pre-K through 6 people. I have a high school problem at the very end that we'll get to one last time for our GK, Praxis core, middle school, high school math people. But I wanted to address some of our K through 6 pre-K people who are also prepping. So I'm going to zoom in on this graph because it's really hard to see. We want to know how many students were surveyed. A second grade class was surveyed, and we are trying to figure out how many students were surveyed. So we've got kids that like chocolate, kids that like vanilla, kids that like strawberry, and kids that like other flavors of ice cream, Rocky Road, mint chocolate chip. In fact, now that we're talking about ice cream, it really makes me want ice cream. So drop in the comments, what is your favorite ice cream flavor? In my opinion, ice cream should be a food group. At the end of this problem, I'll tell you what my favorite ice cream flavor is, because you're not going to want to miss it. You're going to want to run up to the store and buy it as soon as I tell you. So how do we figure out how many students were surveyed in this survey? Well, we're just going to take the total number of students for each category, and we're going to add them up. There were 12 students who chose chocolate. Now, what do I do when I see something like this? Well, it's between the 4 and the 6, so it's going to be 5. It's between the 6 and the 8, so this is going to be a 7. And this is going to be a 2. I'm literally just going to add all of those up, and that will give me the total students surveyed. 12 plus 5 plus 7 plus 2. I am not going to use my calculator for this one because I know that my pre-K through 6 people do not get a calculator. So 12 plus 5, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So my total students surveyed is going to be 26 students. All right, let's go ahead and look at a similar problem, but Same data set, different question. A second grade class took data on their favorite ice cream flavors. Again, what is your favorite ice cream flavor? Let me know in those comments. How many fewer students chose vanilla than chocolate and strawberry combined? Interesting question we have there. How many fewer? What that means is if I have 5 X's and 2 O's, and I asked how many fewer O's are there than X's, what I'm really looking for is the gap here. I have 3 fewer O's than X's. So that said, I need to subtract because I can do 5 minus 2 and get 3. So when I see how many fewer, how many more, 9 times out of 10, I'm going to subtract. But what am I going to subtract? Vanilla and chocolate? Vanilla and strawberry? No, I'm going to subtract vanilla and chocolate and strawberry combined. So chocolate and strawberry combined is going to give me 12 plus 7. So chocolate and strawberry is going to be 12 plus 7, which is 19. And vanilla is going to be 5. So how many fewer are there? I need to subtract my 19 and my 5 to get 14. It's critical that you realize it was chocolate and strawberry combined, which is where most people are going to make their error. Mint chocolate chip and cookies and cream, Snow Monster. Those are both excellent choices. Mint chocolate chip's one of my favorites. Cookies and cream I can't have because I'm allergic to gluten. All right, my favorite ice cream flavor is Santa's White Christmas from Publix. I think Publix is the only store that makes it. So if you don't live somewhere with Publix, I am sorry. But the Santa's White Christmas ice cream, which just came out, they only do it at the holiday season, and they just released it, is literally the best flavor ever. It is amazing. It's in our freezer right now, and it won't take me long to get through the tub because I'm obsessed with ice cream. So that is one of my favorite ice creams, and anything with chocolate and peanut butter, as long as it's not chocolate ice cream. It has to be the vanilla ice cream with chocolate added into it. So how many fewer students chose vanilla than chocolate and strawberry combined? Remember, you got to add the chocolate and the strawberry together and then subtract. Let's go ahead and go to problem 9. The high school band is practicing for the upcoming holiday parade by marching around the school. Their practice route took them an hour and a half from start to finish, including the time that they were marching in place while practicing waiting for their turn to move forward. So like if you've ever been in a parade, you start the parade and you're just marching in place until it's your turn to move. How many minutes did it take for the band to be 1 mile away from the school, round to the nearest minute? So let's take a look at this graph and look at what they're talking about. The distance from school. So I created this graph. Distance from school should really show right here. So the distance from school is there, and this right here is the time that they are marching. So if we look at their distance from school, we notice that from 0 to 1 tick mark of marching, they're just marching in place. And then at what point do they finally hit 1 mile away from school? Right there. That right there is going to be right at the 6. However, we also have to recognize that they marched for an hour and a half. What is that 11 even representing? That's not an hour and a half. If that was a 90, that would make sense, like 90 minutes or 1.5, but 11? What does 11 even mean? The 11 is just the way that the person decided to graph this. And so we have to take our time and divide it by 11 equal time chunks to see when they actually were 1 mile away from the school. That's a really long parade, by the way. When they were actually 1 mile away from the school, because it wasn't 6 minutes. It was 6 time ticks, which each time tick, we have to figure out what each time tick represents, because this whole time from 0 to 11 is 90 minutes. So I have to divide 90 by 11 to figure out what each section represents. And then I have to figure out what that time represents. So 90 divided by 11 equals 8.18, and then it repeats 181818. So that means each little section on my graph is going to equal 8.18, 8.18, 8.18 minutes. So I have to figure out how many minutes it took them to hit that 6. So I'm going to do 8.18 times 6 to get the time it took them to be 1 mile away. So 8.18 times 6 equals 49.08. So that's 49 minutes. When you're doing a problem like this, I know it says round to the nearest minute. Do not round until you get to the end of the problem. Because if you rounded this 8, I just lost my connection. So let's connect back up. Screen mirroring. If you rounded that 8.18 earlier in the problem, what would have happened is 8, like if you rounded the 8.18 to the nearest minute, 8 times 6 would have given you 48, and 48 was not the correct answer. It was 49. So you don't ever want to round until the end of the problem, not in the middle or at the beginning of the problem. Does that make sense? Okay. So if we had rounded that at the beginning, we would have gotten the wrong answer. Now we're lucky we would have gotten 48, and 48 wasn't an answer choice. But sometimes they like to trick us and have like 48 and 49 in there. All right, let's go ahead and go on to our next problem. This will be our last problem of the night. Okay, so this is very similar to the ice cream problem. Same problem, different question. Same set of data, different question, because you could really ask 1,000 questions about the same set of data. The high school band is still practicing for their upcoming holiday parade. Their practice route took them an hour and a half still from start to finish. For how many total minutes was the band stationary? So when we look at a graph like this, how do we know the band is stationary? Stationary means they're not moving any distance. So if we look at this graph, we know they're not going anywhere right here. Because they're marching, time is going on, but they're not getting any further away from the school. The same thing is happening here, here, and here. They are stationary. And so we have to look at, again, because in the previous problem, we already talked about how each tick mark represents a certain amount of time. So when we look at this, we have 1 section, 2 sections, and then this is 2 sections in itself. So 2 more sections. So we have 4 sections of time that they are stationary, but the answer is not 4, because remember, each section represents 8.18 minutes. So I'm going to multiply 8.18 times 4, and I get 32.72, which rounds up to 33 as the number of minutes they were stationary, which means they're just marching and the people in front of them aren't moving. It makes me think of the Macy's Thanksgiving Day Parade, because those acts all come through and then they stop and they perform on that main stage, which is just backing the parade up. Everybody else has to stop and just march in place while that group is performing, and then everybody moves on. So you're stationary for certain periods of time during that parade. All right, we didn't get to finish all the problems. I had some bonus problems here at the end. I had 2 more, but I will go ahead and solve those next week. I'll add those to the front end of my sections of next week. Thank you so much for joining us. For those of you who have still stuck around, Dr. A has a special message for some of you, and a special code for you as well. So thank you so much for joining us. I'm going to turn it back over to Dr. A, and I hope to see you all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.